Once I've cleaned the saw, the next step in the process is straightening the saw. And you'll find that a saw, even from the factory, is not completely straight. And we want to make sure that it is, because if the saw has a little bit of a kink in it, as you run it through the kerf, a little bit of a kink or a bump in there is going to cause friction in your kerf and will cause the saw to run roughly and bind. Another reason is if you're using a saw with one person or single bucking with it, if it has a kink or a bow in it, on the push stroke, it'll tend to buckle on you a lot more than a straight saw will. And the third, and perhaps even more important reason that you want a straight saw is if your saw has a little bit of a kink in it and you put your spider on there for checking the set, the spider will measure differently if there's a kink in it or not. And the result of that will be, if you set your saw to the adjustment of the spider, that your set for each individual tooth will be different, which is important to avoid. You want the teeth of the saw, your cutter teeth, to all have the same set. So those are the primary reasons that you want to make sure that your saw is straight. Now, normally what I'll do when I'm doing a pre-test or just doing a once-over on a saw to see if it's straight or not, I'll hang it by my finger from a raker, and I'll look right down the saw, like this one, looking right down the spine of the saw, or the back of the saw, and that will show up any gradual variations or large bows in it. And that'll give me a good preliminary idea of what I'm going to have to work with in straightening the saw. Using that method probably won't show up small individual bows or variations in the saw. And to do that, we'll test for those using the straight edge, which I'll go into here in a second. Okay, once I've done a pre-look at it like this, then I'll hang it up vertically on some convenient place, and what I end up using is just a nail. And one of the important things about the support is that it let the saw hang freely, so it doesn't have any sideways torque on it, which in itself will put a little bit of a bow in the saw. Okay, once I've got the saw hung, then I need to go over it with the straight edges and determine more precisely where the bumps and the curves are. Now, when I was looking straight down the saw, as I did previously, I had a pretty good idea that there was something serious going on in this part of the saw right here. But I don't know for sure what the shape of it is. I can see what the shape is on the back of it, but it's a possibility that the kink or the bow in it is not going straight across the saw. It may be diagonally to the saw in one direction or another. And the only way of really seeing that is by putting a set of straight edges on it. So I take two straight edges like this, and I put one on either side of the saw, and I'll move it up and down the saw like this. And by rotating the two straight edges this way, I can get a tactile feedback from it. A bump on the saw here, and consequently a depression on this side. The straight edge, which is riding on top of the bump, will rotate very easily, and the one that's on the straight edge that's on the other side of the saw will rotate with difficulty because the ends of the straight edge are in contact with the saw, whereas the one that's riding on top of the bump, it's pivoting in the center. So I can get a lot of feedback just by the feeling of it. Another thing that I get feedback from is looking between the saw and the straight edge. For example, this particular bend here, if we get up here, we can see that there's light under this particular straight edge in the center, and on this straight edge that rocks, there'll be light under either end of it. And of course, another feedback that you get, or indicator, is that the straight edge, which is on top of the bump, will rock. So generally what I do is go up and down the saw like this, and I'll start working on the worst bumps first. This bump right here is by far the worst one. So now, once I've located a bump, what I need to do is figure out what its orientation is. And by that I mean, does the kink or bump go straight across the saw, or is it at an angle? Because if I just place the straight edges on the saw in one place, the natural inclination would be to say, okay, I've got a bump here and it goes straight across right underneath this raker, but in fact it may go off at an angle. So I need to go back and forth the width of the saw to determine the direction of it. So what I'll do, I'll start off, say, at the tooth edge of the saw and say, okay, the high spot here, this part of the saw is right here, and then I'll move back and I'll follow it towards the back to see what the shape of it is, or the direction. Well, this one is running just about right straight across the saw, just about the same location as this raker here. Okay, now in my mind's eye, I'll make a mark on it, or often I just put my finger on it here to mark it. If you need to, you can take a grease pencil and make a mark on it, or you can even spit on it and make a mark on it like that, where the kink is. Okay, once I've done that, then I'll take the saw down and put it on the bench on the anvil and start hammering it straight. Okay, once I have checked the saw for straightness with the straight edges, now I need to actually do the hammering. Now for a hammer, what I use is a sawmaker's cross peen hammer, and it's a specially built hammer. As you can see, the axes of the faces are different. They're 90 degrees from each other. The axis of this one is in this direction, and the axis of this head here, or face, is 90 degrees to that. And these are ground such that it's got a sharper radius of grind in this direction than it is in this direction. And what that does is that it bends metal in the direction of the short axis. So it will tend to bend metal this way. And the reason that's important is you need to bend the kink reverse to what it actually currently is. In order to do that, you need to have the axis of the short radius parallel to the axis of the kink, which means that when you hammer on that, it'll bend the metal this way, but not this way. Substitute hammers can be used. What I used for several years was actually a 3.5 pound, what's called a single jack hammer, just a standard small short handled sledgehammer type thing. But the difficulty with using a hammer like that for straightening saws is that rather than having a face on it that has two different radii grind, they're in essence a spherical grind, so that when you strike the saw, it will not only bend metal in this direction, but also in this direction. And so the upshot of it is, if you have a kink here, you hammer it in this direction, you will also tend to put a bit of a dish in the saw. So what you have to do is turn the saw over and hammer that dish out, so you end up having to work back and forth. It's a much more difficult, time-consuming process than using a cross-peen hammer. So to do the actual hammering process, I want this as flat as possible on the anvil as I can get it. And what I do is I just put some supports under either end of the saw, like so. And this is a very loud process. You definitely need to have hearing protection. So what I'll do is strike the saw a number of times along the axis of the bend, and then I'll hang it back up and check it again with the straight edges. Now, one thing that's very important when you're using a hammer like this is that you keep the axis of the hammer perpendicular to the saw, because if you don't, it's very easy to hit the saw with one of these corners and actually put a dent in the saw, possibly even cracking the saw. So you need to be very careful about how you hold the hammer. It's perpendicular. And when I'm using the hammer, I'm not really pushing down on it hard. I'm pretty much just letting the weight of the hammer do the work. If you have a kink that is pretty significant, you can use stronger blows to speed the process up. If you just have a very small kink in there, then you use fairly light blows. And I usually start from the toothed edge of the saw, or where the gullets are, and move towards the back of the saw. Depending on how much of a kink I want to take out, I may use just 3 strikes, like 1, 2, 3, or I may use 4 strikes, like that, to get more hammer action in there. Now, with a saw that has a fairly sharp kink in it like that, that's quite easily demarked, you're only working in a very narrow area of the saw. But if the saw has a large curve or a bow in it, which can happen if you have left it bent over a saw pack for some time, or bent it quite sharply for transport, you may end up having a section of the saw that's several feet long, in which case you have to hammer the whole saw, where you'll actually say you've ascertained using the straight edges that your kink starts down here. Then I'll actually start down here and take a number of light strokes. So I'll hammer, say 3 strokes, and another 3 strokes, and then move the saw a little bit, and do this sort of thing, and work up the whole saw up to the termination of the bow in the saw. Once I have done my initial hammering, there's a good chance that I haven't taken all of that kink out of there. Well, I'll have to hang it back up again and test it again with the straight edges. And this is it's a process that may take 3, 4, 5, 6 times to get that saw straightened out. So I'll hammer on it a little bit and put it up on the hanger, test it with the straight edges, and then find out how things are, and then I'll bring it back, lay it back on the anvil, and hammer it some more. I'll use a pair of short straight edges. These are just 6 inchers, and instead of using them vertically on the saw or along the axis of the saw, I'll do it across the saw like this, with the straight edges extending beyond the tips of the teeth. If I have a raker that's bent, it will hit one or the other of the straight edges. Normally, a raker will never touch the straight edge in a situation like this. Another thing that as you're running up the saw like this, that you check for is a bent cutter tip. Because of the set, each tooth, each cutter will slightly hit the straight edge, but if you have a cutter which for some reason is bent considerably out of line, you'll become very quickly aware of it. It just hits the straight edge a lot harder. Here's actually a tooth that's hanging up more than the rest of them were, so this one is bent out of line a little bit more than it should be. If you go on up the tooth, or on up the saw, there's another one which has a little bit more set than the rest of the teeth. Okay, that looks pretty good. So this particular saw I'm pretty satisfied with. If I have a tooth that has a lot too much set in it, it's very difficult to take that set out with the normal set adjustment procedures of using a hammer, a small hammer and a small anvil. What I'll actually do is, using the large straightening hammer and the large anvil, there's a lot less chance of breaking a tooth. It's a much easier process to take a lot of set out of a tooth than with a small hammer and an anvil. When I was initially doing the testing of the saw with the short straight edges, and if I were to have determined, for example, that this raker had a serious bend in it this direction, so that as I run the straight edge across like this, I find that this raker is bent this way, and hitting the straight edge, then what I would do, I'll actually turn the saw over so that the convex side of my bend is facing up. That is, the raker tip is actually pointing down at this point. Then I'll actually take the hammer and I'll hammer it here so that it will straighten that tooth out. And then check it with the straight edge and see what the reaction of the hammer is. And if I had struck it enough to straighten it out, then I'd be done. You use the same procedure if you find that you have a cutter tip that for some reason has gotten bent out of the line. One of the difficulties in using a hammer like this with a very large face in between your teeth, your hammer face is actually wider than the distance between your teeth. So you have to be very careful about using the center of the face to bend that, otherwise you'll end up damaging adjacent teeth. One of the things that I